and make sure we can recognize when we have quadratic data. And I say this, you don't really have to recognize it. I'll tell you when I want you to fit a quadratic model to it. Like for example, on the quiz about the speed of sound, I'll say, hey, guess what? It's gravity, therefore it's quadratic. The kicker is when you have a conversation with someone to recognize that you've got that constant acceleration. That's the idea. If you can somehow understand why the acceleration is constant, and we're getting into physics here, but don't worry about that. Just, you'll know when it's quadratic modeling because I'll tell you to put a quadratic model on. So the data is going to look curvy. And Christina, that's why you went straight to exponential, and good for you, because exponential data kind of looks like quadratic data. It honestly does. And we're going to differentiate that next week, exponential versus quadratic. But quadratic data is going to have kind of a predictable curve to it. It's going to have a predictable curve to it. It's going to do kind of like that. And the equation is absolutely gorgeous. It's going to look something like this. And we're going to use our TIs to do this. It gets, Yasumi's like, okay, I've seen this before. I've seen this before. You probably have. If you took like Algebra 2 or you took Math 65 or something along those lines, you've seen this before. Sometimes they have different forms. Sometimes, I'm going to put another one up here and then you can tell me if you like it or not.
No.
Okay. We're good. We'll just leave it like that then. That's fine. That's okay. I'm really gun shy about showing too much stuff in math. I like all the different varieties of math, but students generally don't. So if we don't need it, then we're not going to talk about it. There we go. We're done. We're done. What's that?
I want to see it. Me too.
Go after class.
Yeah, no, seriously, just...
If you don't want to see it, close your eyes. Close your eyes for the next 45 seconds if you don't want to see it.
May not be suitable for all of you.
But
Yeah. Oh, I remember that.
Oh, yeah.
I put this equation on your first project and made you solve it.
Yeah.
I didn't tell you what it was. I just wanted to do, we're working on algebra is all we're working on. Now the reason this one is sometimes used is it isolates what's called the vertex of the parabola, which is nice. But the problem with it is that usually outside of math classrooms isn't the important part. The important part, honestly, is the A value right here. And the level of complexity of that, you can open your eyes again, friends. The level of complexity in this one is generally far simpler. The other reason I like this form a lot better, you see how this is AX plus B? If you cover up that part,
Oh, yeah.
that's the same. That's called the linear component of the quadratic function. That's the part that makes it curve. And exactly, that's the part that I think is like the most badass of the whole thing. So it is.
Yeah.
This is where they should teach it.
Yeah.
There's linear. Hey, watch this.
I like that.
That's constant. Y equals C. Y equals B. That's the constant part. Every time you go up one level of exponentiation, you pick up one more term. If it was cubic, and it will be when you guys analyze Usain Bolt and his sprint speeds, it's ax cubed plus bx squared plus cx plus d.
Oh.
If it goes to 4, it's ax to the 4th plus bx cubed plus, you just keep adding variables and constants and coefficients.
Huh.
And every time you, well, we're getting ahead of ourselves, we'll get into that later. But every time you do pick that up, you just add another term, and that term is what governs the shape. That's why it curves, is that x squared. And hopefully you can see why, right? If you ignore this stuff and only focus on this, you can see what happens as x gets bigger. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. You see? And in a linear function, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 4, 4, 5, 5, 6, 6. Over here, 1, 1, 2, 4, 3, 9, and so forth. You can almost see the bend, yeah? So that's what's governing it. And then it gets even more cool when you start adding the powers. But at the end of the day, this is what it looks like. Fair with me so far?
Yep.
Good. Now, let's figure out what the model is for my bike data. Let's figure out what curve fits my bike data with our TIs, yes? Let's go to our TIs. We'll have just enough time to get into this. We'll crack it open today.